section is going to be about more rules, okay? For example, if we wanted to take the derivative of this, right now, what would your strategy be?
Multiply it all out and then take the power.
Okay, multiply it all out and then do the power rule, right? Could this multiplication be tedious? It could be. Okay. We would have to take 3 terms multiplied by 3 terms. Okay. What if there was a quicker way to take the derivative and having to multiply everything out and then take the power rule every time? Okay. We have a product here. Do you agree? If we are presented with a product, meaning we have a function times a function, then we can use this shortcut using the other shortcuts. So we have power rule, and we know the derivative of sine, and we know the derivative of cosine. Anytime we have 2 functions multiplied to each other, we can use this rule. The derivative of f times g is derivative of f times g plus f times the derivative of g. Go ahead and write it down, and we'll talk it through again. So, Cole, to answer your questions, calculators aren't really needed very much.
Okay. More rule.
Yeah.
Okay.
Okay. So how I like to remember this rule is derivative of the first times the second plus the first times the derivative of the second. Okay? So you have 2 things you're adding together. You're taking the derivative of one and leaving the other one alone, plus leave one alone, take the derivative of the other. Does that make sense? Okay. Derivative of the first times the second plus the first times the derivative of the second. Anytime you see a product of 2 functions, you have to use the product rule unless you want to do the multiplying out and then go from there. Okay? As we go through these rules, you'll see situations where one strategy is better than another. Okay? Now, right now, I want you to put your pencils down. I want to show you why this rule is the way that it is, and I'm going to do it using the definition of the derivative, okay, that limit definition. All right? If any of you are interested in higher level mathematics, like going into pure mathematics, you're going to get to like prove that things are true. And so every once in a while, I will prove to you why something is true. Okay? So if we want to take the derivative of f times g, then we have to take the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x g of x all over h. That means we are finding the derivative. Do you agree?
Agree.
Okay. Now, I'm going to do a trick here where I am going to add 0. Does adding 0 change our value?
No, it does not.
It does not.
No.
Do you agree that that fraction that I just added is 0? Okay, my numerator is the same thing, minus each other, 0. Okay, so I have 2 fractions that have the same denominator. So I'm going to go ahead and add these together, and with the commutative rule, I'm going to rearrange things. Okay, so I'm going to write f of x plus h, g of x plus h, x plus h, plus I'm going to basically flip these two. F of x plus h, g of x, minus f of x, g of x, minus, there should be a minus right here, right? Sorry. So I moved this one over to here, and I moved this one to here, this one to here. Okay? So now what I'm going to do, I'm going to split this fraction in half, okay? Which means I'm going to have two fractions over h. Is there anything in common with these two? F of x plus h. Left over is g of x plus h minus g of x. Over h. So we factored that out. This is what we're left with. Okay. Over here, anything in common? G of x is in common. Left over is, I'm going to rearrange these. F of x plus h minus f of x. Oh. What's the limit as h approaches 0 of f of x plus h? F of x. What about the limit as h approaches 0 of this? What does that mean? Say louder. That's the derivative of g, right? Plus g of x times what's the limit as h approaches 0 of this mean? Derivative of f. That is why the product rule is the way that it is. Whether you remember that or not, I really don't care. But what you need to remember is what I have boxed up here. Okay? So let's practice it. Let's go back to the one that I had on that first slide. This is the example we are going to do first. Okay, so I'm going to underline here in blue and red. So our derivative, we are going to take, since we have a product, we're going to use the product rule. What is the derivative of our very first function? 3x squared plus 2. So we took the derivative of the first function, and then we are going to leave the second function the way that it is. Plus, now we do the reverse. We leave the first function alone and take the derivative of the second. 21x to the 6th minus 16x. Okay? This is a problem where I am okay with you stopping right here. When we get to unit 3, we would have to multiply this out and combine like terms, which is probably just as much work as multiplying out in the beginning and then using the product rule. Okay? But for right now, I'm okay with you leaving your answer like this. The back of the book will have it all multiplied out. Okay? But that's not what I'm worried about right now. Okay. Questions? Let's practice another one. Okay. we have two options for taking this derivative. We can either multiply that x squared through and use the power rule, or we can recognize that it's a product and we can use the product rule. Well, since we're talking about the product rule, that is what we're going to practice, okay? So, dy dx equals, Jake, what's the derivative of our first function? 3x squared times, we're going to leave the second function alone, plus, we leave the first function alone, and Abram, what's the derivative of the second?
2x.
Now, this is a problem where I would like to see you combine like terms, okay? That's not going to be very strenuous for us here. So we can write this as 3x to the fourth plus 2x to the fourth plus 2x, which means our derivative is 6x to the fourth plus 2x.
Yeah, 5x.
Yep, it should be 5x. That's why you pay attention to catch my mistakes.
We learn from each other.
We do learn from each other. Thank you, Cole. Okay? Now, if this was on a question on yesterday's quiz, what would you have done?
Power rule multiplication.
You would have said y is x to the fifth plus x squared, and then you would have taken the derivative to be 5x to the fourth plus 2x. Hey, that's the same thing we got. Okay? Now, right now we're practicing the power or the product rule, so I want you to use the product rule, but come like quiz and test time, you get to kind of make decisions about how you want to take the derivative. Okay? Okay. Another example altogether. This one we don't have any other option. Okay, y equals x squared times sine of x. We have a product, which means we get to use the product rule. Okay. So dy dx. Okay. Everybody is going to help me out. Okay. What is the derivative of the first?
2x
Times
sine x.
sine of x. Derivative of the first times the second plus
X squared.
the first times what's the derivative of the second?
Cosine of x.
Cosine of x. Positive. Okay.
Positive.
Okay. Technically, yes, you could factor out an x. Doesn't really matter. You can leave your answer the way that it is. Okay? All right. We have done 3 examples together. I would like you to do an example semi-independently, like you with maybe a couple other people. But you're not going to do it in your seat. You're going to go to a different part of the room. So you need your notebook and your pencil, and I'm going to tell you where to go. I have 4 corners labeled. What kind of labeled? Corner 1, corner 2, corner 3, corner 4. There's not a label in corner 4, but use process of elimination. Okay? I need you to answer this question and pick the appropriate corner. Would you rather corner 1 have a superpower? Corner 2, meet the love of your life today? Corner 3, never feel tired? Or corner 4, own a time machine? Pick a corner, please.
I'm gonna pick the one without.
Conveniently, I picked the never tired corner to be the one with the couch. Meet the love of your life today. Okay, so nobody wants a time machine, huh? I suppose. So based on the corner, there are your problems. Okay? Superpower, you're taking the derivative of 2x cosine of x minus 2 sine x. Work together. Meet the corner number 2. There's yours. Work together. Corner number 3. Here's yours. Work together. Larry, did you decide to own a time machine? Okay. Do you have a question?
Yeah, I do.
So this would be
So I probably would not want you to leave your precious like I was like,
Times negative.
because right now it looks like x is minus 10. And that's not really what it is. Like if I multiply it changes that.
Multiply by.
Okay, same thing here. Right now this looks like x cubed minus sine of x. I don't really like that. So I would still coach it like this.
What then?
like you cry all the time.
That's all. But it's just like I I don't know.
So like,
So
you took the
most people
derivative
get like
of
basketball courts.
Okay, everybody back to your seats. Took a few steps in. Okay, a couple things that I want to talk about. For both number 1 and number 4, notice how there is addition. Okay, so for this purple one, you have a product rule here, but not here. Okay, so for this product rule, derivative of the first times the second plus the first times the derivative of the second, and then you would subtract 2 sine of x. Or excuse me, the derivative of 2 sine of x, which would be 2 cosine x. Okay? Now, do you notice how I wrote this right here? Do you notice how I wrote this right here? Okay, I know we were having the same thing happen, was it for Never Feel Tired, right? Don't leave it like this. Please rewrite it as minus 2x sine of x. Okay, so my super power people, those cancel out, right? And so you should have been left with negative 2x sine of x. Okay, meet the love of your life today. Your derivative,
6x squared plus 6x plus 2.
you all worked together on that one, didn't you?
You're like 2 people in the group.
So you and Michael?
Yeah.
Excellent, that is the right answer. My never feel tired people. dy dx, okay? 3x squared cosine of x minus x cubed sine of x. Same thing there. I know that this is plus x cubed times negative sine of x. So make sure you actually do that multiplication and move the sign out in front. Okay? I saw some people doing this, and I want everybody to pay attention to this. To me, that looks like subtraction. First of all, when you multiply, it's a good idea to do so with parentheses. You should get in that habit. When you use the product rule, use parentheses, okay? That way you know that this can be written as 3x squared cosine of x minus x cubed sine of x. Okay. And then notice number 4, Larry all by himself back there. Do you need the product rule for 3x squared? No.
Oh, no, not the product rule.
You do not need you need the power rule for 3x squared, plus then you can use the product rule for x cosine of x. Yes, Cole?
Can you not do like the product rule if you put f of x is 3 and g of x whenever equals x squared?
You could, but that's going to be a waste of time because it's the power rule and that's much simpler. Okay? You could, because, and then the derivative of 3 is 0, and so then that's, it is. All right, one more rule today. What if I wanted to take the derivative of this? Is this a product? No, instead it is a quotient. Here's your quotient rule. It's a little bit more detailed. I'm not going to prove this one to you either, so don't worry about that. Sigh of relief from somebody back there?
That was Larry.
It was not Larry.
Thanks. Larry, you're weird. He's a football game. He's bad tired.
Okay, so when we have a function divided by a function, in this case I have modeled f divided by g. Then when we take the derivative of f divided by g, derivative of f times g minus f times derivative of g all over g squared. Okay? The numerator looks like the product rule except there's subtraction, and then our denominator is g squared. Okay? This is a way that I have remembered the quotient rule since I was a senior in high school. Low d high minus high d low all over low squared. What does that mean? We take the low times the derivative of the high, so low's denominator, high numerator, minus high d low, so the top function times the derivative of the bottom function, all over low squared.
That's a song. That's a song.
I don't think that's a song, but like, I think there's like a pop rap song-ish that is, I know what you're thinking of, but it's definitely not about calculus. Okay. All right, so let's practice. have a quotient, we know our derivative is going to look like a quotient. Okay? So, we have low d high, which means we are going to keep our numerator, the denominator, the way that it is. D high means we're taking the derivative of our numerator, which is what? 3. So the derivative of our numerator times our denominator. Minus, we keep the numerator the way that it is, high times d low. What's the derivative of our denominator? 2x. And then you're going to copy paste your denominator, put parentheses around it, and square it. Okay? Now, our numerator, could we maybe make that look prettier?
Yes.
We probably can. Let's do that. Okay? If we distribute the 3, we have 3x squared minus 6. If we distribute the minus and 2x, we get minus 6x squared minus 10x. Do you agree with my distributing? Nobody's saying otherwise, so. Then if we combine like terms, I would write it as negative 3x squared minus 10x minus 6 all over x squared minus 2, the quantity squared. And that is how. Okay. Questions?
No.
Okay. Next one. We're going to talk about this one 2 different ways. Okay? Is it a quotient?
Yes.
Yes, which means can we use the quotient rule?
Yes.
So if we use the quotient rule, what? Just hold on. Okay, keep that in the back of your mind. We're going to look at the quotient rule first.
Okay.
Okay, so the quotient rule. We leave, so low d high, so we leave the denominator alone, times, what's the derivative of the numerator? 3x squared. Okay. Minus high d low, so we leave the numerator alone, times the derivative of our denominator, 2x, all over x squared squared. Okay. Okay, we can probably take 30 seconds and reduce this down, right? So this is 3x to the 4th minus 2x to the 4th plus 2x over x to the 4th. Do you agree? Okay. Which we could then in turn simplify to x to the 4th plus 2x over x to the 4th.
That's what we started with.
No.
No, I know, but it's like the same format.
Which some of us might get crazy and say x to the 4th over x to the 4th is 1 plus 2x over x to the 4th is 2 over x cubed. Yes, it is in the same, it looks similar to what we started with, but it's not the same. Okay? If we start with a quotient, our quotient rule is going to give us a quotient. Okay? Now, Cole said, couldn't we just use the power rule? Okay, let's talk about what we would do if this was a question on our quiz from yesterday. What would you do? You would separate x cubed over x squared is x minus 1 over x squared is x to the negative second. So then if we were to use the power rule, we would have 1 plus 2x to the negative third. Okay, so Cole, which way was quicker?
Probably the power rule.
Probably the power rule. So now you have the opportunity to start deciding how you want to take derivatives. Now, not all the time are you going to be able to, make a decision one way versus the other. Sometimes there will only be one way to take a derivative, but in this case, we had an option. Okay, let's do another one. Okay, when we take the derivative, low d high minus high d low all over low squared. So low d high, we leave the denominator function alone. What's the derivative of the numerator?
Cosine of x.
Oh. Okay. Minus. The numerator function stays the same. Times, what's the derivative of the denominator?
Negative sine of x.
All over low squared. Okay. We have cosine squared plus sine squared all over cosine squared. What's our numerator, Austin?
1.
It's 1. I have a question. Do you have a question?
Yeah, if you do the power rule, that's how much you do.
How could you do the power rule? Because it's not a times x to the n.
Okay.
We just did split.
You just do cosine over negative sine.
Because it's a quotient, we have to use the quotient rule. We can't just take the derivative of the numerator divided by the derivative of the denominator. It does not work like that. When we have a quotient, we have to take the derivative like this. Now, does anybody recognize what our original function really is? Ah, it's tangent. What's another way to write 1 over cosine squared? Ladies and gentlemen, we never have to take that quotient rule again. If you have the derivative of tangent, you know, because you're going to remember it, it's going to be secant squared.
Should we remember those 3 rules? Or not? Like those rules that have like cosine squared plus sine squared equals 1 and
Identities will pop up every now and again, yes. They are in the front of your book if you need to reference them. Like on the front cover of your book, there's like a page that like it says you can tear out, but you won't because you're not going to tear anything out of my book. If you turn it, it's like on the back of that page. Okay. So I was going to do the 4 corners thing again, but we're kind of running out of time. So what I'll do is, so we're going to do So on your gold sheet is your homework. You have the weekend, okay? If you wait, wow.
No, that's not wrong.
Okay. If you wait until Sunday night and you can't remember the product or the quotient rule, what are your options?
Go back to the website and watch the video.
You can watch my video, you can look in your book, okay? You have to attempt these problems, okay? If you do not practice, you will not know what you're doing, okay? So at the 2 minutes we have lunch in class, okay, your gold sheet has your homework, all right? I would like you to pick a corner based on this. Would you rather watch number 1 a sitcom, number 2 ESPN, number 3 a soap opera, or number 4 reality show? Pick a corner.